A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be a part of the lecture 9 in continuation of our previous lecture of lecture 9 under the module 4. At the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. In the previous lecture, we discussed under the mixed design of granular courses that one important aspect at the very beginning is to achieve the target gradation. Now, for different courses, different gradations are given considering different applications. So, there were 6 gradations which we saw specifically mentioned under the granular sub-base courses as per MORTH requirements. Now, similarly, there is a gradation for a granular sub-base unbound course, that is wet mix macadam also. So, when you have different stockpiles of aggregates in the field, you need to proportion it, you need to blend it, and that blend should finally give you a gradation which is within the gradation range, and your target will be to the mid value of the gradation range which is recommended for that particular mix. So, that particular exercise we discussed in the previous lecture. Now, once that is known to you, once you are able to understand, okay, you have the aggregate stockpiles and you have the required gradation range given for that particular mix, you can attempt that blending and reach to the gradation. Now, in addition to that, what else are required specifically? So, when it comes to granular sub-base courses, especially the unbound granular sub-base courses, the materials we have already discussed in some of the previous lectures, that it will consist of natural sand, crushed gravel, crushed stone, crushed slag, or a combination of these materials. So, this under the granular courses, these following materials can be used. Now, so simultaneously, while attempting that proportioning, before that you should also ensure their physical characteristics, because if one particular source is not suitable as per the physical requirements, that should not be considered for the proportioning part also. In some cases, there may be certain challenges with related to some specific property. So, then you have to look what alternate source of material can be there. So, as it is mentioned, a combination of materials can be arrived in that case. So, there may be, if you are using some soil stabilized, which we will discuss in this particular one, then the soil is clay, then you can look for some stabilization through lime in that case. So, similarly, so that possibly the requirements of the materials are met. So, here it says the selected materials have to be checked through characteristics. What important characteristics for material to be used in sub-base courses? Aggregate impact value, liquid limit, plasticity index. It says that liquid limit should be less than 25, plasticity index should be less than 6, and aggregate impact value. We discussed if certain aggregates are susceptible to the to saturation with water, or they have a higher water absorption, then we can go for wet aggregate impact value also. Now, once, as I mentioned, that there are 6 gradations specified by MORTH for granular sub-base courses. So, in that case, whatever aggregate gradation you have targeted, say you have targeted gradation 5. Now, you have attempted the physical characterizations, aggregates are found suitable, you attempted the proportioning and you got a gradation which is within this particular gradation range. Then the next exercise starts under this particular one is to evaluate the water content and density relationship. So, you will do the Proctor test, which we discussed in previous lectures, where you will vary the water content and you will try to determine the density, the dry density, and from the relationship between moisture content and dry density, you try to figure it out, the optimum moisture content and maximum dry density. So, because this is important for the construction of that mix in the field. Now, in addition to this one, you need to ensure what, or you need to evaluate what is the strength of that material, and that is most commonly done in terms of your California bearing ratio, which we also discussed. Now, while preparing the specimens for determination of California bearing ratio, the specimens should be prepared at a density of 98% to what has been achieved at maximum dry density, so as to replicate the field situation. So, we will go for a determination of 98%, and then as I mentioned, the CBR can be determined under soaked conditions and unsoaked conditions also, where when you do soaking, you keep the sample submerged in water for 4 days before determination of the CBR value. So, that gives you what will be the strength which will be retained in the material once it gets indented by under the water. And as the MORTH specifications recommends that the minimum CBR for a material, unbound material for used in a granular sub-base course should be 30. So, if that is also not meting out, you may have to require to change the aggregate source, a particular source you have to change, or otherwise you have to go for some stabilization techniques. So, this is what is required when you are using a unbound granular sub-base course. In addition to this, there is another popular mix which is waterborne macadam, which also we discussed certain aspects of that particular one in previous lecture. Here we will focus more what are the important considerations regarding its construction. So, one important aspect is always the materials to be used under this particular one needs to be ensured for their physical characteristics. So, it says that this is as per there are guidelines information mentioned over waterborne macadam in MORTS 2013 also, and this is a specific code IRC 19 giving the information about the waterborne macadam. Now, here it says that if a waterborne macadam course or a mix is used as a sub-base course, then the requirements for Los Angeles aberration value or aggregate impact value, one of these can be conducted, and if a choice is given to us, preferably go for Los Angeles aberration value. In addition to this, if it is to be used as a base course on the top of which a bituminous course will come up, then the requirements are here. Here you can see the requirements are becoming more stricter when you are using it in upper course. So, when I am using in a sub-base course, the requirement of say Los Angeles aberration was maximum value can be up to 50%, but here it got reduced to 40%. And in certain cases where you are not going to go for any bituminous treatment over the one, it will be directly used as a surface course, then it says that the Los Angeles aberration value again here 40%, but in addition to that particular one, there is a requirement of shape also, that the flakiness index also needs to be determined when this particular is to be used. And this is specifically when some crushed stone or crushed slag is used, this flakiness index is important. Now, again there are different gradations which can be adopted for the construction depending upon the layer thickness. Different size ranges are recommended. Here you can see this is again a table which has been picked up from IRC 19 2005. It says if the aggregates are in the ranges of 90 to 45 mm, at least the thickness should be 100 mm of that particular one. Otherwise, for this particular ranges, typically the thickness of the waterborne macadam can be of 75 mm. So, 75 mm is a quite popular thickness of waterborne macadam which is constructed. Here it says, and this specifically when it is used as a base course, here it says this layer thickness of 100 mm with coarser size of aggregates are specifically when the waterborne macadam is used as a sub-base course. It is used as a sub-base course, then we go for this 90 to 45 mm aggregate size. And for this particular one also there is a complete gradation range is given. This is 90. As I mentioned, this is the range of aggregate particles that should be there. If 100 mm thickness is to be constructed, this is the range of. So, you need to blend the different aggregates available with you to meet this requirement. Now, in the construction of this particular one, once the coarse aggregates are laid and compacted, then screening materials are to be put over that particular coarse aggregate and then again compacted over it. So, for this particular screening also, two sizes of screenings are recommended, grading A and grading B, where this is 13.2. Now, for this 13.2 specifically it refers to the NMAS. So, here it says that this is the mentioning the gradation range for a material which will be classified as 13.2, or the important part is grading A. So, this should be the range of materials which should be present if grading A is used, and this should be if this is used. In addition to this particular one, there is a table which gives how much approximately, because you are going to put that aggregates there, it states how much quantity of aggregates are also applied. So, this is a sort of design how much quantity of different materials are required. So, this is what we did when the granular sub-base course was there, to determination of the amount of water which has to be used, and then the density which can be achieved. Here already it is the table based on the research and field experience gained. It says that when you are going for coarse aggregates in the size range of 90 to 45 mm, then in that case the loose quantity of aggregate should be in this particular range. This is for 10 meter square of area. So, approximate quantities of coarse aggregates and screenings required for 100 mm compacted thickness of WBM. So, this is, as we see, as we have seen in the previous slide, for this particular range the thickness should be at least 100 mm, and it is preferably used as a sub-base course. For this one, the loose quantity of coarse aggregate will be this, and then it says which type of screening can be used. It mentions that if you are using type A screening, which is 13.2, the loose quantity should be 0.27 to 0.3 meter cube per 10 meter square of area. And if this is a stone screenings, there may be certain screenings from which may come from muram or gravel, which are more susceptible towards crushing during compaction. So, there they fix up certain criterias, properties and size. It says that the liquid limit for those kind of screenings which are susceptible to crushing, liquid limit should be less than 20 and plasticity index less than 6, and the percentage passing 75 microns should be less than 10. And in addition to that, the quantity of the screenings in loose quantity is also mentioned. So, the binding material quantity depend upon the type of screenings and function of WBM, whether you are using it as a sub-base course, base course, or it as a surface course. Now, as mentioned, if this was mentioned for 100 mm thickness, if it is for 75 mm thickness, the quantity may be required will be here it is mentioned 0.07 to 0.09 meter cube per 10 meter square when it is used as a sub-base and base courses. So, this is what again it is mentioned, and determining which type of grading it is, depending on the grading also which is to be used. In addition to the screenings, binding material is also applied, and that particular binding material specific criteria is having the binding material should have a PI of 4 to 6, and preferably when it is used on the top, then the PI should be, or otherwise if you are having this particular one binding material is not required, where the PI of crushable type screening is less than 4 especially. So, it says application of binding material may not be necessary where the screening consists of crushable type, because it itself crush downs and serves more or less the purpose what is to be done through a binding material. So, but specifically when this is to be used as a surface course, wearing course, no bituminous top on the top over it, then where the PI of crushable type screening is less than 4, then application of a small binding material having PI of 4 to 6 is required on the top. So, these are some specific requirements regarding the design and of these waterborne macadam. There is another mix, granular mix, which is wet mix macadam, preferably used for the construction or mainly used for the construction of base courses of flexible pavements. Here The one again the requirements in terms of aggregates are in terms of the strength and shape. It says what should be the value of abrasion loss, what should be the value of impact. It says 30%, less than 30% for impact, less than 40% for Los abrasion, and here the requirement is in terms of combined flakiness and elongation index. So, that says that maximum 35% is allowable for this one. And if you are using crushed gravel, in that case 90% by weight of the crushed gravel or shingle retained on 4.7 shall have at least 2 fractured faces. Fractured faces we already discussed, and again in addition to this particular one, the plasticity index of this particular material is to be less than 6. Now, for this material also you are going to determine the maximum dry density and OMC, and then you will work out the CBR of this particular material, and this CBR of the material should be preferably even for use in, and we can estimate, as we have done estimation for the other part also, we can estimate the elastic modulus of the granular materials on the basis of the CBR of these materials, which will be required for attempting the flexible pavement design, because the input parameter is in terms of elastic modulus or resilient modulus. Now, this is the gradation which is given. This is the gradation which is given by IRC 109/2015, which is for wet mix macadam. Here it states that minimum thickness of this layer should be 75 mm and maximum it can go up to 250 mm, but preferably we keep the maximum thickness around 200 mm, which is also defined as stated in MORTS 2013 specifications. And one important aspect even during this gradation or proportioning part is to be seen that if I will look for 2 sieves, if any I have done a proportioning, and where what I found that the material on this 11.2 sieve was 40% passing. So, it was on a lower side. So, 40% material was passing. My target was 50%, but the blend of the different stock piles gave me a 40% passing, but then also since it is the range is given as 40 to 60, so it is in the range, so it can be acceptable. If when I go for the same blend on the second sieve, and if it comes out here it is on the lower side, and there on the next consecutive sieve if it comes on the upper side, so then this can be again 40% passing. That is, here it is more finer compared to what I am requiring. Around 32% was my mid value which I was requiring, or I am targeting of 25 and 40 is the range. So, I will be targeting for something around 32% passing, but here it is 40% passing. Now, what happens, we should not go for this kind of proportion or blending, because here now here 40% is retained, here 40%. So, there is no material which is there between 11.2 and 4.75 sieve. So, this creates a gap grading, and this is not preferable. So, even while doing the proportioning also you should take care, you should apply your own cautious over it to see what is happening, and this will not be accepted if the final gradation approved within these shall be graded from coarse to fine and shall not vary from the low limit on one sieve to the high limit on the adjacent sieve. So, this needs to be again, even they are falling within the ranges, but then also it should not be, because it is the engineer in charge who will take the final decision. And then again, as mentioned, we need to go for the determination of OMC, MDD, and finally the CBR, and from that we get the elastic modulus for use in the flexible pavement design. So, this completes the discussion with the wet mix macadam. In addition to this particular one, nowadays many materials may not be, in certain regions may not be good enough or suitable enough to meet the strength requirements of CBR, or in terms of aggregate individual requirements. Specifically, the strength requirements in terms of CBR may not be, and we require a good quantity of materials for the construction of these unbound granular courses. So, the stabilization of these materials by different cementitious materials is becoming quite popular nowadays, and good information is given in IRC 37 also, in MORTS 2013 also, and even in IRC SP 89 also, on the stabilization of soil and granular materials by using different cementitious products. Cementitious products means one will be cement, it can be fly ash, it can be lime, it can be a lime fly ash combination, it can be a lime fly ash cement combination also. So, there when you are using these materials in this particular one, you need to refer what are the requirements stated for these individual cementitious material. What are the requirements have to be there for cement, for fly ash, for lime, and then what proportion has to be arrived. As we have seen, even in soil, certain clay soils are there, highly clay soils, they can be stabilized by using lime, and when you are using this combination of soil with lime fly ash, you can again attempt, there is one stabilization which is referred as mechanical stabilization, where you can do this blending of different materials in the same manner in which we attempted through the graphical method the blending of the aggregates for these mixes. So, and finally, when we blend these aggregates or soils materials of different sizes, it improves the workability and strength of that material. So, without adding any cementitious product also, by combining 2-3 different products, we can ultimately, without generating any cementitious product, by changing the gradation also, a significant amount of stabilization or strength can be achieved for these materials. So, it says that so you can have cement treated subbases also, you can have cement treated base courses also, and both are mentioned in our IRC 37 guidelines for flexible pavements. It says the material used for cement or cement fly ash treated can be soil, including, as I mentioned, it can be a soil treated with cement, fly ash, lime, a combination of lime, fly ash. It can be gravel, concrete, brick aggregate, crushed rock or slag, or any combination of these materials. So, their combination can be attempted and worked out. Some specific requirements which are mentioned in MORTH, in SP 89 and in IRC 37, they talk about again whatever materials, if you are using aggregates, the aggregate should have aggregate impact value of not more than 30%, combined flakiness index, shape is given, Los Angeles aberration value, when these are requirements related to the aggregates. And for material passing 425 micron, it says the liquid limit should be less than 45 and plasticity index less than 20%, and uniformity coefficient should not be less than 5. Uniformity coefficient gives you an idea, this is the CU, which gives you an idea that how much is the dispersion in the aggregate gradation is there, whether the material is uniform. If the uniform, then your coefficient of uniformity will be less. If so, you always want that this coefficient of uniformity should be more than. Now, in addition, as I mentioned, different cementitious products can be used, and which can be your ordinary Portland cement, Portland slag cement, Portland pozzolana cement, and when they are tested for physical characteristics, these individual components also needs to be evaluated. What cement you are using, that needs to be tested as per the IS requirements, IS 269 and IS 4455, IS 1489, all these are for different cementitious products, different requirements are there. Now, when we are using this treated sub-base course, cement treated sub-base course or cement treated base, IRC 37 recommends that for a cement treated sub-base course, the thickness should be at least 200 mm, and for a cement treated base, the thickness should be at least 100 mm. This is as per IRC 37. So, and then when you are doing this treatment or stabilizing the material with any especially cement, most commonly used is the cement, it says you have to work out the strength in terms of unconfined compressive strength, especially this is done for the your granular materials or the stabilized granular materials. Now, for when you are using that material as cementitious sub base, it says that the unconfined compressive strength should be at 7 days should be in the range of 1.5 to 3 megapascals. So, this is an important requirement, that this compressive strength, unconfined compressive strength of any stabilized material which is to be used as subbase is to be in this one. Now, from once you have this UCS, so it gives a preliminary idea whether this stabilization is good enough for achieving the desired strength. In addition to this particular one, we work out the modulus for us. So, you can say modulus of cement treated subbase is given as 1000 into your unconfined compressive strength, and this is for 28 days. So, and this is the elastic modulus of cement treated subbase, which is, this is as per the expression which is given in IRC 37 2018. It says that from the UCS of 28 days you can get an idea about the elastic modulus of that material, and this elastic modulus will be used in the analysis of flexible pavements or the design of the flexible. And there it says and important consideration is whatever UCS which will be arrived at 28 days should be at least 1.5 times of what is expected in the field, because a lot of variability will exist in the field, especially in mixing, quantities, blending. So, that is why when you do a controlled one at laboratory scale, the UCS determined at laboratory should be at least 1.5 times of what you are targeting in the field. Now, once this is there, this elastic modulus is used in the, or resilient modulus is used in the design of flexible pavements, and this value it says should be restricted to a maximum value. So, by default you can go for cement treated subbases elastic modulus of 1600 megapascals. So, this is, here you get the values in megapascal. This is again the UCS at 28 days in megapascals. Now, similarly, when it comes for the the materials, cementitious materials for use for base courses, it says that the strength should be in the range of 4.5 to 7 megapascals. Now, here again, as when cement is used, there is an early gain in the strength, but in case of other pozzolanic material, the gain in strength takes a longer time. So, that is why it mentions that while the conventional cement stabilized material should attain this strength in 7 days, granular materials and soil aggregate mixtures stabilized with lime, pozzolanic stabilizers, lime, fly ash, etc. should meet the above strength requirements in 28 days, since the strength gain in such materials is slow. So, that is why you need to check for 28 days strength when you are using these lime, fly ash or other pozzolanic materials to ensure, because there the rate of gain of strength may be slow. And again, once you work out this particular one elastic modulus, the one which is as per IRC 37, it advisable for use as this elastic modulus for cement treated is 4000, cement treated bases is 5000 megapascals. This value is used for there. In addition to this particular one, when a cement treated base is used, because thereafter over the cement treated base you will have the a construction of bituminous course will be followed. So, there you need to do a fatigue damage analysis also. For that you need to work out the modulus of rupture or the flexure strength of the CTB material, cement treated base material, and this is important, specifically aspect which needs to be ensured for that material. And there also it says the values of this modulus of rupture can be taken as 20% of your 28 days of UCS strength which you used while determining the elastic modulus, and there again some maximum values are specified. It says if it is a cement TCS stabilized, then this modulus of rupture can be considered as a maximum value of 1.4 megapascals, and if it is a lime fly ash soil, it will be 1.05 megapascals. So, this has to be this one, and if it is a soil cement, it has to be 0.7 megapascal. So, this is again a requirement. In addition to this particular one, when these materials cement cement treated base courses are used so as to avoid any reflection of cracks or propagation of cracks from these cement treated base courses to your bituminous courses. A crack relief layer is also provided, and that crack relief layer can be in terms of your wet mix macadam. 100 mm of wet mix macadam layer can be provided as a crack relief layer, and wet mix macadam gradation already we discussed. So, that particular aggregate interlayer can be provided over, is preferable to be provided over cement treated base, and then over that particular, and that here in this case it is usually compacted to 100% of its density, which is your MDD laboratory derived density. So, in some cases instead of this aggregate interlayer, they put certain stress absorbing membrane interlayer, where you put a layer of modified binder over the surface of it, followed with some stone chips, and then you go for the construction of bituminous mixes. So, that stress absorbing membrane interlayer, where only application of binder with some aggregate key aggregates are there, that is not considered as a structure component. That stress absorbing membrane interlayer, but these two layers, whether aggregate interlayer or this stress absorbing membrane interlayer, which will be a bituminous layer, modified bituminous layer, this will not be considered as a structure layer. This can be considered because this is a 100 mm of WMM, which is, but they help to prevent any propagation of cracks or transfer of cracks from the cement treated base courses to your bituminous courses. In addition to this requirement, one requirement is in terms of durability also when you are going with these cement treated base courses, because they may be subjected to different wetting and dry cycles or different freezing and thawing cycles. So, it says if this material is subjected to a wetting and drying cycle, the minimum quantity of cementitious material is to be decided based on that in such a way that in a wetting and drying test, this is a test which is a specified BIS, the loss of weight, because when you subject any this cementitious base to this wetting and drying, I am not going into the depth of the test procedure. Here you can get an idea, the loss of weight is determined through this particular one when a specimen is subjected to wetting and drying cycles. So, it says the specimen has to be subjected to 12 cycles of wetting and drying, and the loss of weight should not be more than 14%. So, this is when there are chances that this particular layer are exposed to more of water, and there can be a subsequent wetting and drying can happen. In addition to that, in colder regions or snowbound regions, it may be preferable to evaluate the durability in terms of freezing and thawing cycles. So, there again 12 cycles are applied as per the BIS 4332, and again the weight loss is mentioned that it should not be more than 14%. So, this completes our discussion specifically on the different aspects related to your granular courses, material, the blending of aggregates, the determination, the mix design in terms of determination of the blend of materials, the amount of water content and the density, possible density achievable, the determination of the CBR, the requirement of the CBR, the requirement of strength in terms of the modulus, elastic modulus for cement treated base courses, cement treated sub base courses. So, with this particular one, now we will go for we will complete this discussion here for unbound courses, both unstabilized one and the stabilized one. Thank you.